Welcome to our video on pipelining in computer architecture. Today we will explain what it is pipelining, and what is the core principles of pipelining, and how to solve the problems, and we will comparison between impact of pipelining. First, pipelining is a technique where multiple instructions are overlapped in execution. Each instruction passes through different stages, like in an assembly line, to improve performance and increase throughput. Typical 5 stages in a pipeline: 1. If, instruction fetch. 2. Id, instruction decode. 3. X, execute. 4. Memory access. 5. WB, write back. Second, let's talk about core principles. Imagine you have a factory that builds cars. If only one worker is responsible for building an entire car from start to finish, the process will be slow. But if we divide the work into stages, and each worker specializes in one stage, like assembling the engine, painting the body, or installing the interior, then a new car can come off the production line much more quickly. Like here in the picture. Third, but pipelining isn't always perfect. Sometimes, issues arise due to overlapping instructions. These are called hazards. One common type is a data hazard, which happens when a later instruction depends on the result of a previous one that hasn't completed yet. Look at the code here. The second instruction needs the result of the first. But in a pipeline, it might execute before that result is written back in the WB stage. Why wait? With forwarding, we skip the delay. The result goes straight from X or MEM to where it's needed. No stalling is a technique used in pipeline processes to send data directly from one stage to another without waiting for WB. 1. If the result is ready in X, it can be forwarded directly to the X stage of the next instruction, X forwarding. 2. If the result is not ready until MEM, then it can be forwarded from MEM, X forwarding. This avoids unnecessary stalling, inserting NOPs or delays. Sometimes forwarding can't resolve all hazards. Load use hazard is a special case. See code here. T0 isn't ready until MEM, but the add needs it in X. Even with forwarding, it arrives too late. Solution: stalling, insert a delay cycle. Superscalar architecture. It is a design that allows the processor to execute multiple instructions in a single clock cycle. In other words, there are multiple pipelines working in parallel, with each pipeline handling a different instruction. This significantly increases the instruction throughput and therefore greatly enhances the overall performance of the processor. Real-world example: the Intel Core i7 processor, especially models from the 10th generation and beyond, makes extensive use of superscalar architecture. The second solution is dynamic scheduling. Instead, it reorders instructions intelligently at runtime. 1. Powered by advanced control units inside the processor. 2. Helps to maximize hardware utilization. 3. Ensures the correct program result is still produced. What's the result of these advancements? Here we comparison between two things which are modern process and older process. While modern process contains 1. Multiple instructions per cycle. 2. Superscalar or parallel execution. 3. Deep pipelining. 4. Dynamic or out-of-order execution. And 5. Faster and more optimized. The second thing is older process, so 1 instruction per cycle. 2. Sequential execution. 3. Simple or no pipelining. 4. No dynamic scheduling. 5 is slower and less efficient. Here we compare between two things. Impact of pipelining, which is pipelining splits instructions into multiple stages, increasing system complexity. Requires precise control units to ensure proper instruction flow. Needs accurate synchronization between pipeline stages. And second thing is higher power. Increased stages and logic consume more energy. Power rises due to running multiple pipelines in parallel, complex control logic and hazard handling. Summary of the video: pipelining, a technique that divides instruction execution into stages, allowing multiple instructions to be processed simultaneously. Data hazards: problems occur when one instruction depends on the result of another that hasn't finished yet. Forwarding: data bypassing, sends results directly from one pipeline stage to another to avoid delays caused by data hazards. When forwarding isn't enough, sometimes forwarding can't solve all hazards, so the processor adds stalls, pauses. Superscalar architecture, a design that uses multiple pipelines to execute more than one instruction per clock cycle. Dynamic scheduling. The CPU doesn't follow the original program order. Compare between modern process and older process. Finally, thank you for listening. If we have any questions, connect with us in comments.